Hi everybody, welcome back. We just finished chapter 9 in the last video. Feel free to check that out in case you missed it. That was actually the end of part 2. We are going into part 3, which covers networking, security, and maintenance. We're going to deal with chapter 10 today, which is configuring network and internet connectivity. Again, back in chapter 1, we talked briefly a little bit about networking, but very, very shallow. We're going to dive a lot deeper today and go into more details of chapter 10, which is configuring network and internet connectivity. Now, our main objectives for chapter 10 is that we will be able to understand basic network terminology. We're going to be able to choose, set up, and configure a SOHO router. We're going to choose between wired, wireless, cellular, and satellite connectivity, and also use a LAN to share files and printers. All of that and more coming up in this video for chapter 10. The first thing we need to talk about is the difference between these two major network types, which is LAN and WAN. Now, LAN stands for local area network. It typically covers a small area, such as a home or a small office, and these are computers that are connected via either cables or Wi-Fi signal, or a combination of the two through a connecting box, which is called a switch. We'll talk more about switches here in a little bit. A LAN is typically in a home or a small office, and it was often used for a SOHO network. Now, a SOHO stands for small office, home office, such as just a small office with just a few people in a room or in a small building, or our home, which has a living room and a kitchen and a dining room, and we want to be able to connect to this network no matter where we are. Now, there's a couple different ways that we can set up a SOHO network. One is with a wired connection, and the other one is with a wireless connections. And a wireless local area network is called a WLAN. This is where devices within a network connect wirelessly. As you can see from this graphic over here, we've got 3 different workstations and then 2 laptops. So we have 5 different computers that are being connected together through a network, and we need a switch to be able to do that. The 3 desktop computers are being wired into the switch, but however, we do need to have this WAP, which is wireless access point, so that way the 2 laptops can also connect and share resources and share files. And that's what the major purpose of a network is, to be able to share resources within this network. The other type is called a WAN, and a WAN represents a wide area network. This typically covers a large area, a larger business, or a college campus where you have a lot of other LANs around. And that's what a wide area network does, is it connects 2 or more LANs together. The largest WAN in the world is the internet. It's a worldwide network connecting millions of computers. Whenever you access the internet, you're actually accessing a server or a machine on a different LAN, and it could be right down the road, it could be in the same city, it could be in the same state, the same country, or it could be in a different country or all the way across the world. The internet connects us all together, and it is the largest wide area network. As you can see in this graphic here, we actually have 3 different LANs. We have this LAN down here, we have this LAN down here, and we have 1 LAN up above. All of these are able to connect to each other using a switch. However, if one LAN wants to connect to a different LAN, this switch has to be connected to a router, and that router is connected to an ISP, which is an internet service provider. Whatever that internet service provider is, such as Comcast or AT&T or Verizon or whatever, this internet service provider will then allow you to go through and connect to a different LAN. Now, there's a few different types of networks that you can have for either a LAN or a WAN. The first one is a client-server network. Let's talk about what each one of those words represents. A server is a computer or a device that manages and shares resources to other computers, such as files and folders and printers. It also provides central storage of files and can provide services to the users. The users that it provides services to are called clients. Clients are computers who access the shared resources on a network. Typically, it's a workstation or a laptop, but it can also be a game console, a smartphone, a DVR, a tablet, or any other mobile device or permanent device. So a client-server network is where one or more computers acts as a server while the rest of them are clients. An example that you would see this at is a business or a school. This is where you have a dedicated server room which has a bunch of computers kind of in a closet, and they take care of anything and everything from throughout the building. And if you as a client want to be able to communicate to the internet or communicate to another person's computer, you would have to go through the server for it to be able to allow you to do that. Now, that's for typically a business which has a large number of devices it takes care of. You can also do another type of network called peer-to-peer. This is where every computer is both a client and a server. There is not a separate server room, and I want you to think about your home. Your home has a network probably if you've got internet at home, and there is not a dedicated server room at your house, but instead each device and each computer can either receive files or send files, and that means each device is either a server or a client. So it's called peer-to-peer, which means one computer to the next. This is the most typical to share resources and the most typical in a small office or a home office network. So a small office, home office network not only is a peer-to-peer, but it's also within a LAN. Once you get out of the LAN, you're now in the WAN, and that's typically a client and a server. You can also do online peer-to-peer. Online peer-to-peer is where you share files through the internet. You can either go to a file sharing website such as BitTorrent and upload your files that way, and then somebody else can go into the internet. And typically this is through an FTP website, and then someone else would access that FTP website, which is File Transfer Protocol, and then they can download those files from the internet. Again, it's not as safe as going through peer-to-peer or client-server, but that is one way that you could do it. Now for LAN connections, remember that in order for two things to connect with a LAN, you need to have a switch. Again, a switch is for how local computers can connect to one another. If it's a wireless device, you will need a wireless access point, also known as a WAP. And typically there is a box that you can buy that has all of these wrapped into one. Not only is it a switch, but it's also a WAP. A lot of those are also a router. As you look at this graphic, these two desktop computers can connect with an Ethernet switch. They hardwire into the device. But then this laptop over here doesn't have a hardwire, it's wireless. So they can connect using a wireless access point. And this one box over here is both a switch and a wireless access point, and they connect everyone together in this LAN. Now for a WAN connection though, remember you not only want to connect to each other within your LAN, but you want to leave your LAN and connect to another person not in your LAN. They are in their own LAN, so you need a WAN to be able to do that. If you look at this graphic over here, you have the same setup. You have these two desktop computers and a laptop, and they all connect to the switch and the wireless access point. But then that one is connected to a router. I'm a router, and I connect this LAN to the ISP's network. That router goes into a cable modem. I'm a cable modem, and I provide the broadband connection from the ISP. And that one then is connected to your ISP. Your ISP is the internet service provider, as I mentioned before, such as Comcast, AT&T, other ones that might be local to your area, and then they allow you to then go out and connect to other LANs across this town or across the city, across the state, across the globe. So a router is a central box that connects two or more LANs together, and they act as a gateway between the LAN and the ISP. In order for you to properly set up a SOHO LAN, you need a few things. You obviously need a client, which is a device that you're trying to connect. You need a SOHO router, which is also typically a switch and a WAP and a modem. They're all kind of like an all-in-one bundle, and that allows you to not only talk to those people nearby, but also talk to these people across the street, across the country, wherever the other LAN is. You also need to make sure you have access to an ISP, an internet service provider. These are the people that you probably pay your internet bills to. they not only allow you to have your router, but then they hook up to their internet provider. So that way they can hook you up to the next LAN or the internet. A couple other ways that you can set up a network within your home is that you can do an ad hoc network and also a direct link network. Now, a local ad hoc network is where you're joining a few computers together through a direct connection, typically wirelessly. Windows Vista, Windows 7, they used to offer an ad hoc network option on their operating system. However, now Windows 8, 8.1, and Windows 10 have removed this option due to security risks. Whenever you're doing it wirelessly, you're always opening up your susceptibility to be compromised. So anybody else on that wireless signal could possibly hack in and see what kind of data you're transmitting or get into your computer. So Windows 8 and Windows 10 have removed this option. However, you can always do a direct link network, which is a one-to-one connection using Ethernet ports. Typically, this is computer to computer. If my computer is trying to connect to my neighbor's computer and I want to do this as secure as possible, I would use what they call a crossover cable. I would take this crossover cable, I would plug it into my Ethernet port on the back of my computer, they would plug it into their Ethernet port on their computer, and we can transmit things this way. Now, this is great if you're near each other and you can literally connect a computer to computer with a cable, but it's not great if you're across the room or a different room or things like that. Remember, you are going to use your Ethernet port for this. However, you don't use an Ethernet cable. There's a specific cable that you would use called a crossover cable. And this is one way to securely transmit information from one computer to another using a direct link. So if you're in the market to buy a new router or to get a new router for your home or home office or small office, there's a few questions you need to ask yourself of what kind of router do you want to buy. Now, you do need to find out whether you need a wired only or a wireless. You're probably going to choose both. You're probably going to be choosing wired and wireless, but you definitely want to make sure that it has wireless capabilities. With the increased use of smartphones and tablets and other wireless devices, you want to make sure there's a way for you to connect to the network wirelessly. You also, though, want to make sure that you do have a wired connection. And what you'll look for is on the back of your router, whether it has these internet ports, these Ethernet ports. There are 4 of them on the back of this, and that's what I would recommend. You at least have 4. You can get others with 6 or 8, but 4 should be the minimum because you could possibly have more than one connection that you're using. For instance, at my home, I have my smart TV hooked up directly into the router, so I need to make sure I have a spot for the cable with that. I also have my Blu-ray player with a wired internet connection, and so that's plugged in, and that already takes 2 of these spots. If you've got other things nearby that you want to make sure you have the strongest connection to, such as streaming videos or other things that need to access the internet, a smart device, you will want to make sure you use that. So 4 might not be enough, but it could be depending on what you're doing. So once you've chosen a router with not only wireless capabilities but also wired capabilities, you need to decide what wireless standard do we want to use. And the best wireless standard that's currently out there is what they call the 802.11ac. And that is the best current version because it has the fastest connection with the slowest lag and a lot of other great things going on. We're going to talk about the different ways that you can connect and how wireless can be better than others later on in this video. Some other ones that are out there are 802.11n, 802.11g. There's some other letters as well you could possibly get, but again, you want the best one right now that's currently available, which is AC. Now, there's other considerations that you should always look at when you're choosing a router, but none of them are on the exam. The only things you need to know for the exam purposes is whether it's wired wireless, 4 Ethernet ports, and 802.11ac is the best current wireless standard. Now, if you notice, there's another port back here that just says for internet. This is what your internet service provider's broadband box will plug into, so that way your router is sending off the appropriate signal and also wiring in the appropriate signal. So you are going to connect via an Ethernet cable, and you do want to not only set up your router, because a lot of them are ready to just plug and play. You plug them in, you do everything you need to, and it's ready to go. However, a lot of people don't realize you can configure your SOHO router, and it's highly recommended that you do these few changes that I'm going to talk about to make sure that your network is as secure as it needs to be. So how do we make these changes? That's a great question. We want to make these changes typically when we first set it up, and you need a computer to be able to do this. Now it's best with a direct or a wired connection. And what you would do is once your router is set up and ready to go, then you would take a cable, an Ethernet cord, you'd plug it into the back of one of those ports that we talked about and plug it directly into your computer. You would then have some things available to you. Now, before you do this though, you want to make sure that you have a good connection, that your computer is being connected to the router. So you're going to look for blinking lights on both the router itself. There should either be some lights on the top, on the front, or on the back, depending on your brand and model. You also want to check for blinking lights on your NIC, your NIC, which is your network interface card. Wherever you're plugging that Ethernet cord into on your computer, look near that spot. You should have some blinking lights to indicate that you do have a strong connection and that things are working well. Once you've done this, in your documentation that came with the manual, you should have an IP address. Your IP address is a series of numbers separated with periods. The example on this graphic is 192.168.0.1. You would open a browser, and you do not need to have internet connection to do this. There's actually its own little program within the router that allows you to be able to go in and make changes. So you would open a browser, you would enter this IP address into the address field, hit enter. It would then take you to a welcome page like you can see here in this version. Now every version is going to be a little bit different. Again, it depends on the brand and the model of your router that you're dealing with. You would then plug in your username and the password. Again, this should be in the documentation of the router that you purchased. You can then, once you plug these things in, you would hit log in, and then you would be able to do some changes that are necessary for the setting. This is what the Belkin router setup screen looks like. Now this is our setup screen for Belkin router. Again, everyone looks a little different, but somewhere you should have a list of menu options, and then here in the middle you've got whatever you chose for what you want to do. The interface screen is very specific to each brand of router, and again, the options are similar, but they might be laid out in a different manner. After you log in, one of the first things that you want to do is that you want to change the password, the router password. What this does is this stops anybody from logging in to your router to make the changes that we're getting ready to make on here. It's very important to do this because most default login usernames and most default login passwords are easily found with a simple internet search. If someone knows the brand of your router, they can go online and they can find a list of the default passwords that are handed out. And if you haven't changed it with just a little bit of trial and error, someone can go into your router system and be able to do this. So this is one of the first things that you should always do, and you want to change this to something that you will remember or put in write down and put in a safe place. Again, the process depends on the brand of your router, but this is sometimes this is the first step in security, and it's going to prompt you to do this, but I would highly recommend, whether it does or doesn't, that you do it. And you don't have to do it when you get a brand new router. You can do it right now with an existing router and go in and change what that default password is, as long as you know the current one, which again should be in your documentation. The other thing that's important to do is for you to update the SOHO router firmware. Now remember, firmware is nothing more than programming stored on the chip inside of the device to perform the device's basic functions. It's kind of like the operating system for the router. Now, who knows how long this router has sat on a store shelf or in a warehouse, so it might not have the most up-to-date settings within the router. So you do want to check for firmware. You do need internet connectivity to be able to do this. When you click on what it says over here, check firmware, it's going to check the internet and see if there's a newer version out there. If there is, you want to make sure you upgrade it. Now sometimes it will do an automatic search and automatic upgrade for you. Other times you will have to visit the website of the manufacturer and then find the latest firmware version, download it as a file, and then here where it says choose file, you would choose the file that you downloaded and put it into this, and then that would be the way that you could update the firmware. Again, it depends on the make and model of your router on the steps that you need to take, but I always recommend that you update the firmware if necessary. The other thing that I want to talk about is that you should always make sure you change the SSID. Now, your SSID stands for Service Set Identifier. Service Set Identifier is what you see when you look at the available Wi-Fi networks. Whenever you click on the Wi-Fi signal, you usually see all the different available networks within your area, and then you choose the one that's yours. Well, you will have a default one being named, and typically the default network is named after the brand of your router. So it might say Belkin 123 in this case. You never want to leave it as the default SSID for a couple reasons. Number one, people will automatically know what brand that you have, and if you've left the SSID the same, odds are you've left the router password the same, and they can easily search for Belkin passwords, find it, trial and error, and get into your system. So make sure you change it, and you don't want to change it to something that's very confidential. I would even stay away from names or dates or pet names or things like that. Anything that's confidential that you might end up using as a password before or now. But you want to make sure you make it something unique to you to make it easily identifiable for you and the people that are going to be using this network. But you want to change your SSID. In this example, as you can see, underneath wireless, it says channel and SSID. You can go in and change it. They changed it to sycamore_null. And then you can also change what kind of wireless mode you want. And if you have an AC mode, if you have an AC router, you want to make sure you choose the AC mode. The other thing I want to talk about with the screen is it says broadcast SSID. This is really nice because, again, if you keep that checked, whenever anybody is looking at nearby Wi-Fi connections, they're going to see yours. If you uncheck that, it's still going to be available for you to use. It just won't come up as an option on available Wi-Fi networks. So that way you're protecting yourself that only the people that you knows is there can use it, and other people who are trying to find ways in won't see it. So it's really nice. But this is called the SSID. That is the network name. Now, with wireless security, when you set up your Wi-Fi network, again, you want to keep it as secure as possible, and you do want it to be password protected. That's very important. If you leave it open network, then anybody can get in there and possibly get into your stuff. Now, a wireless security is very important. It's a system of authenticity for the wireless clients that connect to your router. If it's an open network, there is completely no security. Without a password, it doesn't do anything. So the network can offer free internet and shared files to the public if it's open, and that's not good. So we want to use one of these authentication standards. We're going to talk about all three of these: WEP, WPA, and WPA2. We're going to start with WEP. WEP stands for Wired Equivalent Privacy. Now, this is what was first created, which was better than an open network. They use a 40-bit encryption, which means 40 digits of ones and zeros to scramble the data. However, there were major security flaws in WEP. It's easily crackable, again, as in within a couple of minutes, so we never want to use this. Of the three options we're going to talk about, this one is the least secure. What was made to replace this was WPA, which stands for Wired Protected Access. Now, this was the medium security of these three. However, before WPA2 showed up, this was the best. This replaced WEP. You can encrypt usernames and passwords, and you can also use an encryption standard called TKIS, Temporal Key Integrity Protocol. Again, this is great. However, it is still crackable, but they did introduce encryption, and they did introduce a few things that made things better for your wireless access. But then someone came up with one that was even better than this, and that's what is always preferred. This one is the most secure, WPA2, the most secure authentication method for a SOHO wireless network. This uses an encryption standard called AES, which is Advanced Encryption Standard. Possible WPA2 options do include the default key and WAP-PSK. And what this is a password shared with people who need access, but often it's less secure because it's created to be easily remembered. So if you are going to use a pre-shared key, kind of make it something obscure or make it something that so that people can't easily guess it. However, of these three, WPA2 is the best of the best. That's the one that's going to be the most secure for you. But if WPA2 is not an option, WPA is always better than WEP. So you got your router set up. It's important for you to be able to do that. And you then want to connect things to your network. Now, obviously, if you have a desktop computer or a laptop or a phone or a tablet, then you can easily just click on the Wi-Fi signals, click on yours, put in the password, and you're good to go. However, there's a lot of smart devices out there now that don't have keyboards. They don't have a keypad for you to type in the username or the password or what the Wi-Fi network is, such as a home automation device, such as a speaker, such as a wireless printer or an MFD, a multifunction device. These things don't have keypads for the most part, so you can't just easily type in the password. So we have a couple options though using WPS, and this stands for Wi-Fi Protected Setup. These are methods to connect a client with the router. They can either be turned on or turned off when you configure your router. The first one is called PBC, which is push button configuration. All you do is you press a button, and you can see that here in the graphic, the WPS. This is our push button configuration. If you press that button, the router will accept new connections for a brief time. So if you've set up, let's say, a wireless printer and everything's turned on and you're looking to connect to a network, you would click on the printer, connect to a network, then you would press this button on your router. And immediately it's going to accept any connection out there that's looking for a network. And so then on your printer, it will say network found. Do you want to use this network? And you just press yes, and you're automatically in. And you don't have to put in a password, you're automatically there. Now, as you can probably imagine, there are some risks involved. If other people are looking for a network at the same time you push this button, it will also accept that network or that device as well. So you want this to be a limited time, and you want to make sure you're doing it at a time when no one else is searching for a network. So that's one way to do it, using a PBC. Another way is using a PIN, which is personal identification number. And all you do on the device is you enter the PIN number and connect, and it's really nice that way. If you've got a keypad but not a keyboard, you can do it using a PIN. And then the last way is an NFC, which we talked about with mobile phones or mobile devices. It stands for near field communication. It allows the device to connect if it's very close to the router. We talked about NFC using for Google Pay and Apple Pay. It's where you swipe or you put it right next to the payment method, and it will then pay it through your phone device. Well, this is the same way. If you got a mobile device that you're trying to connect to the network, you can just pass it by your NFC-enabled router, and it'll allow you to be able to connect that way without any kind of need for a username or a password. Now, when you're wanting to connect to a Wi-Fi network, and most of us are pretty familiar with this, whether it be a laptop, desktop, mobile device, all you do is you click on the Wi-Fi signal. That's what they did down here. They clicked on this Wi-Fi network right here, and then this popped up, and you can see the ones that are available to be able to connect to. And you just select one, you then put in the proper passphrase, and you're good to go. Now you can see on this example they put Sycamore Knoll. That's the one they changed it to. And then there's this ATT4Y4D4E8. You can tell that this router is an AT&T router, so it's not very secure. You'd want to make sure you change that to something custom. Now, if it's a mobile device, which again most of us I believe are very familiar with, you go to your settings, or you can just simply go to a quick shortcut of a pull down or drag up, depending on if you have Android or iPhone, and then click on the network button. You'll then be able to, or turn on Wi-Fi, maybe if you'll need to do that. Then you'll be able to see the list of available Wi-Fi networks. You choose the one and you put in the proper passphrase if it's needed. The next thing I want to talk about are the different ways that we can connect. These are the connectivity options. Now, one was left off here. It says comparing wired, wireless, and cellular. I also want to add in satellite. There's a fourth connectivity option, which is satellite. So we're going to talk about the advantages and disadvantages of all four of these: wired, wireless, cellular, and satellite. And I've broken this down into 7 categories. We have mobility, availability, bandwidth, which throughput is also part of that, latency, reliability, number of concurrent connections, and security. We're going to talk about what each one of these categories represents, and then which one of these 4 connectivity options is better than the rest. And it's important to make sure we choose the right technology for a certain type of situation that we have. So the first category I want to talk about is mobility. Mobility determines the range of access, or basically how far can you travel and still access the network resources. Now, going from best to worst, satellite is the best. Now, when we're talking about mobility, you're trying to figure out how far can you go and still have access to this type of connection. And honestly, wherever you are in the world, there are always anywhere from 3 to 4 satellites available to reach you. So no matter where you go, you are always going to be able to be connected to satellite. So that is the best. Cellular is next because really there's cell phone towers every couple of miles now. It seems like no matter where you go, you have a cell phone tower that's pretty close to you, and it can be either 3G, 4G, 5G, LTE, but it's available nearly everywhere with different speeds. Next is wireless. Now, typically you can go anywhere from 100 to 250 feet from your wireless access point. I would probably say it's closer to 100 than it is 250 feet. But as long as you're within range of your wireless access point, then mobility is not a problem. However, if you leave your house and you go down the street, then you're out of your Wi-Fi range, and then you're done. But you can still go down the street for cellular. You can still go down the street with satellite. And then the last one for mobility purposes is wired. And wired, again, you're only as mobile as the length of your cable. Now, technically, you can go up to 100 meters, but not very many cables are purchased like that. So you would want to make sure that you are, most cables come between 6 and 10 feet. And again, you can't really walk very far before the wired stops you from moving anywhere else. So regarding mobility, satellite is the best, then cellular, then wireless, then wired. The next category I want to talk about is availability. Availability is defined as the probability that a system will be available and functional. From best to worst, wired is the best, because if you are wired into a network, it is available all the time. However, with cellular and satellite and wireless, this can often suffer from interference. You're not always going to have things available from you depending on what's going on between you and your Wi-Fi signal, between you and your cell phone tower, between you and the satellite. So there could possibly be interference, whether it's electromagnetic interference, weather that's going on, bad weather systems, or whatever. So wired is the best for availability. Next is throughput and bandwidth, and let's talk about which each one of these are. Throughput is the data transfer rate. This is the actual amount coming through. Bandwidth is the size of the connection, the maximum amount. So think about a pipe. How big the pipe is your bandwidth, but what's actually coming through the pipe is your throughput. In terms of throughput and bandwidth, the best option is wired. Wired offers the highest speed and what we would say the fattest pipe. This can be anywhere from 1 to 10 gigabits per second. After that, wireless is best. It often offers the speed of 11 megabits per second if you're using ADHO 2.11g, all the way up to 1.3 gigabits per second if you're using ADHO 2.11 AC. So if you're trying to download music or download a video or stream a video, it's always better to use wired compared to wireless. You're going to have the best speed and the best chance of getting the throughput that you want. Next would come cellular. Speeds for a cellular device can be anywhere from 300 megabits per second if it's 4G, and then 5G, which is relatively new right now at the time of recording, is anywhere between 500 megabits per second all the way up to 10 gigabits per second. Now that compares to wired, 10 gigabits per second. However, 5G is still being used and still being tested, and you're not often going to be in the best 5G spot as well. So it just depends on where you are and how strong the network is at that particular case. So we're putting it third. And then finally, the satellite is the worst. Yep, it's available anywhere that you go, but the speed of it is much less superior than it would be on some of the others. It goes anywhere from 25 to 100 megabits per second. The next category is latency. Now, latency is another word for connection delay. It is the connection delay between a request and a response. Whenever you're typing in a website and you hit enter, www.google.com, and you hit enter, how fast of a delay that is between hitting enter and it coming up on your screen is considered your latency. If it takes a long time, there's a high lag or a high latency. If it's a very short response time, then it's a very quick latency, a low latency or a low lag. Of our four things that we're talking about, wired will offer the minimal latency. Electricity is very quick, so it's not going to take very long for that signal to go out and come back. For wireless, a shorter distance will offer lower latency. If you're very close to your WAP, to your wireless access point, it's going to be better than if you're at the very far edges of it, where it's barely connected. After that, cellular, because it has to travel to the cell tower and back, depending on how far that cell tower is from you, could often dictate how quickly that the response will come back. And then satellite, as you can imagine, satellites are way far away, miles up into the air, so it has to travel to the nearest satellite and come back, which will be the lowest latency out there. We want the one with the best latency, or the one with the minimal latency, the one with the least delay. So wired is always first for latency. The next one is reliability. Now, reliability is defined as the quality of the data received and the error checking and correcting capabilities of the technology. How good is the data from the sender to the recipient? Now, there's always going to be some things that don't end up coming through. When you're watching a video, there's some parts of the screen, some pixels that don't end up coming through. So the technology is smart, and it will error correct or error check and correct those mistakes. So that's really great, but how reliable are these four different options for connectivity? Again, wired takes the cake. It's the best. It has rock solid networks with minimal interference. As long as you're wired in, you're going to get great reliable networks. Then after that, we kind of group them all together: wireless, cellular, satellite. They all suffer from similar interference issues, although cellular and satellite can possibly get some weather delays or some weather interference as well. But even Wi-Fi can have some interference issues. If there's other things going on, if there's electromagnetic interference, or a lot of people using the wireless network, it can slow you down. So it cannot be very reliable compared to wired. The next category is the number of concurrent connections. And what I mean by this is how many clients can use this network at once. The simultaneous access by users. From best to worst, wired scales almost infinitely. As long as people are wired in, you can put as many concurrent connections on at the same time. You can have 5 people using the internet, 10 people using the internet. As long as they're all wired in, it's great. Think about a school. Think about a school and how many people are wired in at schools with desktops and laptops of the teachers, and maybe a computer lab and things like that. They're all accessing wired connections, and it's really good. However, wireless are not sometimes as good when you're at school. Satellite is next because you can sometimes have thousands of users using satellites. Cellular is next. It can go from hundreds to thousands of users. And cellular technology is pretty amazing because if one cell tower is overrun, it's going to bounce people over to another one that will work just as well for them to keep it under a certain number. And then finally, wireless. You can only really have a limited number of users on a wireless connection, so it's not as good as the ones above it. But wired is always best whenever you're doing concurrent connections. Our last category is security. Now, security is defined as evaluating risks involved by using the connections. Is there a chance that your network can be hacked and data stolen? If there are, that's not a great security option. So the best security option, where it's not a good chance of your network being hacked and data stolen, is again wired. It's hard to tap into a cable, and if someone does tap into a cable, I think you'd probably see it. It is very, very secure. After that, cellular, where the phone companies and mobile device developers offer exceptional security. Again, all these major companies out there that are saying buy a cell phone plan through us are not going to get a lot of a lot of traffic and a lot of purchases if they do not offer exceptional security. If people are being hacked all over the place, people are going to jump ship and go somewhere else. So they really work hard to make sure that their company is very secure. But wired is still much better and less of a risk. Next is satellite. Satellite has a lot of space for data to be intercepted. As you can imagine, between you and that satellite are miles and miles and miles of empty airspace. There's a lot of places where somebody can intercept that data. And the last one is wireless. Now I put it down here at the end because if there is no security on a wireless connection, it definitely belongs down here at the bottom. But if you know what you're doing and you have a high user reliability and you're using WPA2, you could put that up above cellular someplace between wired and cellular, and it could be very good. But if your encryption is really bad or there is no encryption at all, it belongs down here at the bottom. It's the least secure. All right, so before we move on to the next thing, I just want to remind you that of these 7 categories that we talked about, wired was the best of all of these with the exception of mobility. Remember, you cannot walk very far if you're wired in. Satellite is the best for that one. But after mobility, which wired came in dead last, wired is completely first place on all these other categories. So please remember that. Wired is always better, except when it comes to mobility. The next category that I want to talk about is how to be able to share files and printers on a LAN. Now, sharing files and printers is important. Whenever you're connecting to a network for the very first time, a box is probably going to be popped up on your computer screen, especially if it's a laptop or a desktop, and it will say one of 3 things. It will either say home, work, or public. And you have to tell the computer which one of these networks is it. Is this one of your home connections, home networks, a work network, or a public network? If you choose either home or work, it will loosen the network security settings. You're basically telling them, I trust this network and it's okay, and it's going to loosen it a lot. However, if you're putting in that it's a public network, it will greatly tighten the network security settings, and it will disable what we call file and printer sharing. Now, file and printer sharing is an option that can be turned on and turned off, as you can see from this graphic. If it's turned on, people can get into the files and the printers that you're sharing and look at them. However, if it's turned off because it's a public network spot, then nobody can get into any of your files or your printer sharings. So it's important to make sure you tell the computer whether this is a home or work network, which is a trusted place, or whether it's a public network, which is a very dangerous place. And anytime you go to a public hotspot, whether it's at a fast food restaurant or a social gathering like a mall or a movie theater, you never want to do anything very confidential. You never want to be looking at bank records or making bank purchases, bank transfers, or any kind of item purchases with a bank card, because it's very dangerous and people can intercept that. So file and printer sharing again allows you to be able to share things, and that can either be turned on or turned off. Now there's 3 types of network organizations called work groups, domains, and home groups, and we'll talk about all 3 of these. Work groups enable users to share access to files, folders, and printers. The users do have to belong to the same work group, and usually by default, a PC is going to be belonging to a single work group called work group. And you can't have multiple work groups on a single LAN. If you've got a big corporation and this little office over here of accounting wants to be in the same work group, they can call it an accounting work group. And then over here in the sales, they have their own little office, they can call it a sales work group, and so on and so forth. So you can have multiple work groups on a single LAN. The next type is called a domain. Now, a domain requires 1 or more computers to act as the controller, which is the host that stores usernames, passwords, and permissions of every single user. Users can really log in from any computer within that domain, and this is often what you see at schools and libraries and the sort, where people could jump around from computer to computer. They have a single sign-on, which means they can then use their own username and their own password to sign in and look at all of their stuff, and any computer would work for them. However, it does have to require a dedicated domain controller, which again keeps track of everybody's username and everybody's passwords and everybody's permissions, because not everybody, if you think about a school, teaching staff and a student should not have the same permissions. Teaching staff probably has more permissions than a student does. And the last organization category is called home group. This enables computers to connect with a common password, and you can often share libraries of data, and there is no usernames involved with our home group. Now, keep going with that category with home groups. As I mentioned, you can share libraries of data among any computer on that LAN. This is only available in Windows computers 7, 8, and 10. This is not usually available with Macs or with Linux or with Chrome. It's really only a Windows thing. And the benefit of having a home group is that it's easier folder and printer sharing than it would be for work group or domain. Again, it only has a password, and that's it, and that password can be shared among whoever you want. But then, as you can see over here in this graphic, you can select what you want to share out: pictures, music, videos, documents, or printers. You can share all this stuff out, and as long as somebody has the password, they can get in and access this information. Now, how do we share? If we have, you created a file, you created a folder worth of files, and you want to share that out with your work group or with your domain, how do we do that? Well, if it's within a work group or domain, there's really a couple different ways that we can do that. And I'm going to walk you through it on this slide. I'm also going to show you an example using using my computer as well. What you would do is you would find what you want to share, and you would right-click on the folder. You then have a couple of different options. You can either do regular sharing or you can do advanced sharing. Once you right-click, you're going to have the properties. You would select properties, and the properties box would pop up. You would then click sharing tab. You can either click share on there and then go through the options of who you want to share with and what permissions do they have, or you can click advanced sharing, and then you can go through a little bit more details of what you want to share. And here's the two examples of that. Simple sharing just goes through this, and you can add people to this, and then you can basically give them permissions of what you want to do of this particular file or folder. Here's who I want to share it with, and here's what they can do with it. Or for advanced options, you can choose specific people that you want to share it with, and you can do it this way as well. So let's go to an example that I already have pulled up. Again, if I have this is my Windows Explorer box. If I want to share this pictures, and pictures has a whole bunch of stuff in it. I want to share all these files with everybody on my work group or on my domain. So what I would do is I would right click, I can go down to properties, click on the sharing tab, and I can just click share right here and then add in who I want to. I can make it be everyone, or I can find specific people within my network, and then I can then do my different permissions for that particular person. Or another option is to go down to advanced sharing. Instead of share here, you can go to advanced sharing. You can do the same thing. You click share this folder. You can call it anything that you want. You can change it if you want. You can change how many users can have access to it. If you only want 2 users at a time to look at it, that's fine. If you want 10 users, as this is default 20 users, you can put any comments about what you want those people to do. You can then do permissions. And then again, you can add people to this group, and then you can say what they're allowed to do. Full control, they can change it, they can read it only. It all depends on what you want to do. A third way of doing this, instead of share or advanced share, is to right-click on the file or the folder, and you can go straight down to give access to. And you can remove all the access so that way nobody can see it, or you can go to specific people, and as you can see, this kind of looks straight into what advanced sharing was. And you can change who it is and what their permissions are. Now, if someone has shared files with you and you want to access those shared files, there's a couple ways to do that. You do have to do it through File Explorer, which is just Windows Explorer, the way that you can look at your different things. And then you click on Network. And let me show you what I'm talking about. In this folder again, over here in my navigation pane, I've got Scrolling down a little bit, I've got a network setting. Now, if I was hooked into my school network or to a business network, then once I click the down arrow right here, which nothing's hooked up right now, once I click the down arrow, then a whole bunch of different computers would be accessed. And if you know that you're wanting to get a file from a certain person's computer, you would find their computer, you would open it up, and then boom, there is everything, every shared file that you want access to. And then you can choose the one that you want, and you're good. Some of them will prompt for credentials if it's a work group, so you'd have to identify your username and your password, but then after that, you can click remember my credentials and you wouldn't have to do that anymore. But that's a way for you to access it. You would go through File Explorer, click on Network, find the user that you're sharing it with, and find the shared folder. And then again, put in the credentials if you need to. The last thing I want to talk about in this chapter is sharing printers. Now, you can install and share printers a couple different ways. It really depends on the type of printer that you have. If it's a network-enabled printer, which means it's plugged directly into the network, and then you want to access it from across the office or across the school or across the classroom, you can do that. You can go into, if it's a network printer, as long as you install all of your drivers and you install their printer on your computer, you should have access to it, and you should be fine as long as you have the right permissions. However, if this printer is directly connected into your computer and you want to share that out with other people that you're working with, you would have to do this. You would go into that particular printer that's installed on your computer, you go into their properties, you click on the sharing tab, and you would check mark share this computer. Now, you can call it anything you want to. If you want to call it my computer or Mr. Joe's computer or whatever you want to do, you can do that. Or you can call it by the printer make and model. And then you would just simply hit OK. And then anybody can go into your printer on their computer and print things off, which is a really nice way of doing it. So that way you don't have to get a computer for every single person. All right, so that covers everything from chapter 10 dealing with networks. Hopefully you were able to understand a lot of this. Feel free to go back and look at those videos. As always, comment down below if you have any questions or comments, and I'm happy to answer those questions to help you prepare for your U61 IT Fundamentals Plus exam. As always, I've got a few questions to kind of go over as just kind of a review to look on as we start going through to see how much that we knew. Now, again, these review questions are not comprehensive, but they are just kind of a pick and choose of the different things that we talked about. So feel free to look back, study any part of this video first before we do that, and then we can come back at the end of this video and go through the questions. So the first question I want to talk about deals with which of these terms best describes a SOHO network. Choose two. A, peer-to-peer. B, client-server. C, WAN. D, LAN. Two answers. Feel free to pause the video if you want to think about it before we reveal the answers. Now, SOHO, remember, stands for Small Office Home Office. A small office home office is in a LAN. So that's the first answer. LAN. D. The other one is that a SOHO, if you think about a small office or a home office, your home does not have a server room. So if it doesn't have a server room, it cannot be client server. So a SOHO is often peer-to-peer. So the definition of a SOHO network is that it's a peer-to-peer network within a LAN, local area. Second question, what differentiates a router from a switch? A, routers are for WANs and switches are for LANs. B, a router provides a path out of the LAN, such as to the internet. C, a switch provides a path out of the LAN, such as to the internet. D, routers are for client-server networks and switches are for peer-to-peer networks. The answer for number 2, and there's actually A or B, would work. However, the correct answer is B. This is the major difference between a router and a switch. A switch does not allow you to get out of your LAN. A router allows you to leave your LAN to go to the network. Now, A is correct. Routers are for WANs and switches are for LANs. But what differentiates a router from the switch is that a router allows you to get out, whereas a switch does not. So 2 is B. Number 3, when shopping for a SOHO router, look for the latest available standard, which is A, 802.11b, B, 802.11ac, C, 802.11n, D, 802.11g. The best and the latest available standard that we want to go with all the time is 802.11ac. Number 4, what kind of ports are on the back of a SOHO router for making wired connections? A, VGA, B, DVI, C, RJ45, D, RJ11. On the very back of a router, we said we want at least 4 Ethernet ports, and an Ethernet port is the same as an RJ45 port. You would put an RJ45 cord into an Ethernet port. So 4 is C. Number 5, how do you access a router configuration utility? A, buttons on the back of the router. B, buttons on the back of the router. A, buttons on the top of the router. B, buttons on the back of the router. C, IP address in a web browser. D, domain name in a web browser. You access a router configuration utility by typing in a IP address in a web browser. Number 6, what is a router's SSID? A, network name, B, IP address, C, serial number, D, model number. An SSID is what is broadcast out there. Whenever you look at your available Wi-Fi networks, each one of those available Wi-Fi networks is the SSID. So the SSID is the network name. Number 7, which wireless encryption standard is the most secure? A, WEP, B, WPA, C, WPA2, D, WPS. The most secure is WPA2. WPS is not an encryption standard. That is your Wi-Fi protected setup, which is different ways that you can connect a client to the network. All 3 of these, remember, least secure, medium secure, most secure. So C. Number 8, in which way is a cellular internet connection superior to wired and wireless? A, bandwidth, B, mobility, C, number of concurrent connections, D, security. We talked about on those 7 categories, wired is the best of the best, except for one. And the only one where wired is not the best is mobility. So in the only category in which cellular internet connection is superior to wired and wireless is mobility. You can walk around a lot more with a cell phone connection, a cellular connection, than you can with a wired or a wireless. Number 9, what is the advantage of using a home group? A, higher security level. B, easier folder and printer sharing. C, makes router use less power. D, faster file transfer. The benefit of using a home group, as we mentioned in the slides earlier, was that it's easier to share your folders and share your printers. Finally, number 10, where in the control panel would you go to connect to a network printer on a client PC? We didn't really talk about this, but think about it. In the control panel, you want to connect a printer to a computer. So in the control panel, where would we go? Don't make it difficult. For a printer, you would go to Devices and Printers. Okay, great. Thanks for joining me for Chapter 10. Hopefully this helps you to understand networks and all the different things that goes with it a little bit better. Feel free to review this video as much as you can. And again, as always, feel free to leave comments down below. I'm happy to answer any questions or any comments that you have. I appreciate you joining me with this chapter. We will meet again in Chapter 11. Thanks again, and as always, keep on keeping on.